Okay, so in this lesson, we continue our discussion about writing an equation of a line, but in this part, in part C, you're going to be given 2 points on the line. So recall in the previous 2 lessons, the first part A, was writing an equation of a line where you were given a slope and the y-intercept, and part B was where you were given the slope and another point on the line, or a point on the line. All right, so notice though in both cases, and you're going to see this in a little while, in both cases, in part A and part B, the common word here in both of those when you were writing the equation of a line is the slope. All right, so the slope. So in part A, you were given the slope and the y-intercept, and in part B, you were given the slope and a point on the line. So in this lesson, though, you want to write the equation of a line, but this time you're only given 2 points. That's all you're given, just 2 points. Okay, so let's kind of review something from the previous 2 lessons with regards to equations of lines. So when you looked at the previous 2 lessons, you noticed that in part A, we used the slope-intercept form directly. And in part B, to write the equation of a line where the slope and a point was given, we went directly to point-slope form. We substituted into point-slope form. Okay? So in part C, where you're given 2 points on the line, we're still going to use the idea of point-slope form. So remember, point-slope form is y minus y1 equals the slope times x minus x1. That's point-slope form. Okay, so that's what you're going to use. You're going to use point-slope form. And remember, in order to use point-slope form, you need to know two things. You need to know the slope and a point on the line. Okay, so that's what you need to know. All right, so let's look at the directions that you're probably going to see with regards to part C. So let's find the equation of a line that passes through the pair of points, and then you want to write the equation in both slope-intercept form and standard form. So that part where you're writing the equation in slope-intercept form and standard form, we did that part in part B of the series in this lesson. So let's look at this example. Suppose we had, number 1, suppose we had these 2 points, 6, 2, and 1, 5. So 6, 2, and 1, 5. Okay? So, again, you want to write the equation of a line. So in order to use that point-slope form, you need to know 2 things. You need to know the slope and a point on the line. The slope and a point on the line. Slope and point on the line. In this case, I know 2 points. I know this point and I know this point. But the problem is I don't know the slope. So if I'm going to find the equation of a line that passes these 2 points, I've got to find the slope of that line. So let's find the slope of the line. So remember, the slope formula is y2 minus y1 over, now remember it's rise over run, so you're subtracting the y coordinates, and that goes in the numerator. You're subtracting the x coordinates, and that goes in the denominator. But the order matters in terms of how you subtract the x coordinates. So if I do y2 first, then I have to do x2 first. So it'll be x2 minus x1. And remember what we did when we found the slope was we label these points. So let's call this x1, y1, x2, y2. All right, so the first thing you're going to do when writing an equation of a line where 2 points are given, you have to find the slope first. Okay, so step 1, find the slope. All right, so step 1, find the slope. Okay, so we just plug and chug. So we get m equals y2 is 5, subtract y1 is 2, divided by x2 is 1, minus x1 is 6. So 5 subtract 2 is 3. 1 subtract 6 is a negative 5. So the slope is a negative 3 fifths. Negative 3 fifths. That's the slope. So we tend to where we have 3 divided by negative 5, we tend to make the fraction negative by putting the negative sign in the numerator. So just go ahead and put in the numerator. It's going to help you when we do the next part. All right, so that was step 1. Now remember, in order to find the equation of a line, where 2 points are given, I've got, and I'm using this point slope form, I've got to know the slope and a point of the line. So now I know the slope. I know the slope of the line is negative 3 fifths. I know that slope now. And then I need to know a point for the line. Well, here's the situation. I have 2 points in this line. It does not matter which one I use. It does not matter which one I use. And make sure you understand why it does not matter which point I use. Okay, so let's make sure we understand why it does not matter which of these points I use. So I'm going to go ahead and graph this line just to kind of explain why it does not matter. So if I graph this line, I have these 2 points, 6, 2. So 6, 2 is in the first quadrant. And I have the other point, 1, 5, which is also in the first quadrant. And so when I graph this line, I get this line. And notice that this line falls from left to right, so the slope ought to be negative, and it is. We saw the slope is negative. So the line does fall as we go from left to right. The y values are decreasing as we go from left to right. Okay, now, to find the equation of this line, remember, we need to know the slope of this line and a point of the line. It does not matter which 2 points I use. Regardless of which 2 points I use on that line, and there are an infinite number of points on that line, it does not matter which point I use, that point and that slope define this equation. So whatever the slope is and whatever point I have on this line, that equation will represent this line. It does not matter. And I'm going to do this both ways, and you'll see that you'll get the same equation. Okay, so step 2 then is to use point slope form. So y minus y1 equals the slope times x minus x1. Okay, so now remember, in order to use point slope form, I've got to know the slope, which I now know is negative 3 fifths, and I got to know a point on the line. So you determine which of these points you want to use. It does not matter. So let's say we use this one, and then I'll do it again where we use this one. You'll see you'll get the same equation. So we're going to use this point, 6, 2. So let's call this x1, y1. So we're going to substitute that into our formula. So we get y minus y1, which is 2, equals the slope. So the rest of this is from the previous lesson. So if you recall, lesson B, this part right here, all of this that we're about to do is the same approach. So y minus 2 equals the slope, which we found to be negative 3 fifths, times x minus x1, which is 6. All right, so remember, this is point slope form. That's point slope form. But we want to get it in slope-intercept form. So just like we did in part B of these lessons, we're going to distribute, and I get y minus 2 equals negative 3 fifths times x is a negative 3 fifths x. A negative times a negative is a positive, but I need to figure out what 3 fifths times 6 is. So I cannot reduce. There's nothing to reduce here. So I'm going to get 18 fifths. I get negative 3 fifths x plus 18 fifths. Okay? All right, then we're gonna get y by itself, so I'm gonna add 2 to both sides. And so I get y equals negative 3/5 x plus, and then I can do this by hand, 18/5 plus 2, or I can use a calculator. All right, if we use the calculator, I gotta find the calculator. All right, so if I use the calculator, I have 18/5, a positive 18/5 plus 2. So I'm going to say 18/5, 18 divided by 5 plus 2 equal, so I get this decimal. So remember, you're going to, if you don't know what 5 and 6/10 is, you should. 5 and 6/10, so that's 5 and reduced, that's 3/5. And then write this back as an improper fraction. So 5 times 5 is 25. 25 plus 3 is 28. So I get 28/5. So that's what this should be. All right. So if you now remember, you have access to a calculator, so you didn't have to do that. You could have just used your calculator. So 5.6 or 5 and 6/10. We're going to change that to a mixed number. So that'd be, remember, you do second PRB. So you're going to change the decimal to a fraction, press equal, and you get 5 and 3/5, which is what we saw here. Okay, now you just got to change it to to an improper fraction. All right, so this becomes 28/5. Okay, so this is slope-intercept form right here. That's slope-intercept form. Slope-intercept form. All right, so the slope is negative 3/5, which is what it should be based on this. And what we see now is that the graph is going to cross the y-axis at 5 and 3/5. All right, now if you didn't have access to calculator, just remember how to do this. You're saying 18/5 plus 2 divided by 1. So the LCD is 5, so you're going to write equivalent fractions. So you're going to write 2 fractions with that denominator. All right, so you want to rewrite 18/5 with a denominator 5. Well, we already had the denominator 5, so that means the numerators will have to be the same. So 18/5 is equivalent to itself. Over here, I have 2 divided by 1, and I want to write an equivalent fraction that's equal to some number divided by 5. So we're going to say 1 times 5 is 5, and whatever I do to the denominator, I do to the numerator. So 2 times 5 is 10, and so 2 divided by 1, or 2, is equivalent to 10/5, which makes sense because 10 divided by 5 is 2. So notice, once the denominators are the same, I get 18/5 plus 10/5 is 28/5, which is what this was. Okay, so that's slope-intercept form. Now remember what we did in the previous lesson was we now need to convert this back to standard form. So remember, standard form, I'm going to go ahead and use this right here. So standard form, remember, so standard form is ax plus by equals c. That's standard form. So ax plus by equals c, and no fractions. All right, so no fractions, no decimals. So you want these to be, a, b, and c, to be integers. A, b, and c are integers. Okay, and we tend to write the x term first. Okay, so let's talk about, now remember we learned this in the previous lesson in part B. So let's remember how we did this from the previous lesson. So we got to find the LCD, so the LCD is 5. We're going to clear the fraction, so the LCD is 5. And so I'm going to rewrite this, y equals negative 3/5 x plus 28/5, and so I'm going to multiply both sides by 5. So times 5 times 5. Now remember, we enclose parentheses because there are more than one term on this side. So I get 5y equals, and then we're going to distribute. So remember, the whole point of multiplying by the LCD is to get these denominators right here to be 1s. And we do, because look, 5 times negative 3/5, 5 and 5 is 1, 5 and 5 is 1, so 1 times negative 3 is negative 3. So 5 times negative 3/5 x is negative 3x. Plus, and then 5 times 28/5 is just 28. All right, now remember, we got to get this in standard form. So that's not standard form right here. Standard form is where you bring all the variables to one side, constant on the other, and no fractions. And we tend to put the x term first. So to get the negative 3x to the other side, to get the x term to the other side, I'm going to add 3x to both sides. And let's put the x term first. So I get 3x plus 5y equal, that's 0, 28. So that is that is standard form. Standard form. And what we saw also is that you could have also written it as negative 3x minus 5y equal negative 28. That's also an equivalent standard form. So remember, all we did was, if you refer back to the previous lesson, we multiplied both sides by negative 1. So negative 1 times 3x is negative 3x. Negative 1 times positive 5y is negative 5y. Negative 1 times 28 is a negative 28. Which also means that you're just taking the opposite of each term. Okay, so what I found so far, with regards to this, and on that worksheet or a test, you're not going to graph this. You're gonna do these problems just like we did. So that's going to be your work right here. I just brought in the graph just to kind of explain that regardless of which point I use, the equation of this line turns out to be y equals negative 3/5 x plus 28 fifths. And if you look at this, remember we said that the y-intercept was 5 3/5. Kind of looks like it's 5 3/5 right here. Okay. All right. Now remember though, when we first talked about this, we said that in order to find the equation of the line, given 2 points, we first of all had to find the slope. Okay, that makes sense. We need to know the slope of the line in order to find the equation of the line. That's a given. We have to know the slope. And I also have to know a point on the line. Here I was given 2 points. When I did this one, I used this point here. Someone else could have used 1, 5. It did not matter. So let's do that. Let's do this one. Let's do step 2. But instead of using 6, 2, let's use the ordered pair 1, 5. And you will see that you'll get the same equation. Okay, so let's do that. So this is still number 1. But we're going to use the point 1, 5. Okay, so the slope of the line is negative 3/5. All right, so y minus y1 equals a slope times x minus x1. So here's your x1, here's your y1. So we're using this point this time. So that's your x1, that's your y1. So I get y minus 5 equals the slope, which is negative 3/5, times x minus x1, which is 1. All right, we're going to distribute. Oh, and by the way, this is point-slope form. All right, and remember what we're going to do now is we're going to write it in slope-intercept form. So we're going to get y by itself. So we're going to distribute first. So negative 3/5 times x is a negative 3/5 x. And a negative 3/5 times a negative 1 is a positive 3/5. All right, now we're going to add 5 to both sides. Combine like terms. I get y equals negative 3/5 x. And then using your calculator, 3/5 plus 5. So 3 divided by 5 plus 5. Second PRB, press equal, and you get 5 3/5, which is what we had earlier. So remember 5 3/5 right here. 5 3/5, which is 28 fifths. I get plus 28 fifths. So there's your, so you get the same answer. Slope-intercept form. So it does not matter which point you use. Okay? All right. Now let's look at number 2. So suppose now that number 2 is this. So let's look at this problem now. And number 2. We have negative 8, 5, and negative 9, negative 6. Negative 8, 5, and negative 9, negative 6. Now, I'm sorry, before we go on, so notice that using this point first, I got this equation of a line, and using this point for the next time, I got this equation of a line. I want you to notice that regardless of which point I use on this line, notice the slope, regardless of what I use, the slope's the same. And so if I find the equation of a line, given the slope and any point of that line will always be this. Okay? All right, so let's go back to number 2. So number 2, we have this now. So we have these 2 points. So if you want to find the equation of a line, regardless, whatever equation you're dealing with, you're going to need to know the slope. So let's find the slope first. So step 1, find the slope. So let's call this x1, y1, x2, y2. So remember the slope formula. The slope formula is y2 minus y1 divided by x2 minus x1. And so in this case, the slope is going to be negative 6, y2, subtract 5, divided by, now since I started with y2, I have to start with x2. Negative 9, subtract a negative 8. So the numerator here, negative 6, subtract 5 is negative 6 plus a negative 5. And then be careful with this one. Some students have trouble with something that looks like negative 9 subtract negative 8. So you need to be on the safe side, change this to an addition problem. So this becomes negative 9 plus the opposite of negative 8, which is a positive 8. So my numerator is a negative 11, and my denominator is a negative 1. Negative 11 divided by negative 1. But you need to be able to notice, don't leave it like this, you need to be able to notice that first of all, a negative divided by negative is a positive, and 11 divided by 1 is 11. So this is just 11. So my slope is 11. Okay, now let's step 2 is to find the equation of a line. So in step 2, we're going to use point slope form. Okay, so y minus y1 equals the slope times x minus x1. And so I know the slope, and I just need to know a point of the line. And I know 2 points of the line, does not matter which one of these I use. So let's just use this one here. So we're going to use negative 8, 5. Now after we do this one, you may want to pause the video and then use the other point just to see that you will get the same answer. Okay? All right. So this is going to be my x1, this is going to be your y1. So you can plug that into the formula. So just plug and chug. So the rest of this is from lesson B. So I get y subtract y1, which is 5, equals the slope, which is 11, times x minus an x1, which is negative 8. Now, just like we did in the previous lesson, remember, you need to rewrite this. So don't leave it as x subtract negative 8. You will probably, if you're not careful, make an error somewhere around here. So rewrite this as x plus 8. So this becomes y minus 5 equals 11 times x plus 8. Now, remember, this is point slope form. Okay, point slope form, the directions that you want to write the equation, the slope-intercept form, in standard form. All right, so this is point slope form, both of those. Okay, so let's write in slope-intercept form. To write in slope-intercept form, you got to get y by itself. So we're going to first of all distribute. So you get y minus 5 equals 11x plus 11 times 8 is 88. And then finally, we're going to add 5 to both sides. Combine like terms, I get y equals 11x plus 93. So your slope is 11, and then it's going to the line's going to cross the y-axis at 93. All right, so that's your slope-intercept form. Okay, now you want to write this in standard form. So standard form is where you bring all the variables one side, constants to the other, no fractions. So if you compare that to the previous one, number 1, see you had fractions here. So you had to multiply by the LCD. Here there are no fractions, so you don't have to worry about multiplying by the LCD. You just bring the terms, the variable terms on the left side or the right side, does not matter, and a constant on the other side. Okay? So I'm going to go ahead and rewrite this over. So I'm going to subtract 11x, and let's put the x term first. I get negative 11x plus y equal, that's 0 here, and I get 93. So there's your standard form. Okay, standard form. Now again, someone else could have written 11x. You remember, you just take the opposite. So if you had brought the variables to the right side, constant to the other, you would have gotten the next one. So you would have gotten 11x. The opposite of y is negative y, equal the opposite of 93 is negative 93. Okay, so either one of those is fine. Now make sure you understand why you get this with regard to, let's look at this right here, y equals 11x plus 93. So when the work we did here was we brought the terms to the left side. So I could have brought the terms to the right side. So I would have subtracted y from both sides. And so y minus y is 0. So I get 0 equals 11x minus y plus 93. And then subtract 93 from both sides. I get negative 93 equals 11x minus y, which is what this is. Okay? All right, so that was number 2. Okay, let's look at number 3. Number 3. So you may want to pause at this point and instead of using negative 8.5, go ahead and use negative 9, negative 6, and see if you still get the same answer for slope-intercept form and standard form. You should, because these points are on the same line with the same slope. Okay. Number 3, suppose we had these 2 points, 4, 5, and negative 6, negative 6. So 4, 5, and negative 6, negative 6. So again, you want to find the equation of the line. You're given 2 points. So if you're going to find the equation of a line, you have to know the slope of that line. That's a given. You have to know the slope of the line. So that's going to be your first step in this case. And then when you're given 2 points, first thing you got to do is find the slope. You can't go directly 2-point slope form. You can't do that because you don't know the slope. So you got to find the slope. So let's call this x1, y1, x2, y2. And so the slope then would be y2, which is negative 6, subtract y1, which is 5, divided by x2. Since I started with negative 6 for y2, I got to start with negative 6 for x2. Subtract 4. And so my numerator, negative 6 plus a negative 5, and my denominator, negative 6 plus a negative 4, that becomes negative 11 divided by negative 10, which is 11 tenths. Okay, so you got to know that a negative divided by negative is a positive. So that's your slope. All right, now, so that was your step 1. Step 1 was to find the slope. Now, step 2 is to substitute the information into point slope form. All right, point slope form. Okay, so y minus y1 equals the slope times x minus x1. So in order to write the equation of a line, I got to know the slope and a point on that line. So I know the slope now. The slope is 11 tenths. I just got to use one of these points. It doesn't matter which one. This time I'm going to use this one. So let's use the point negative 6, negative 6. So this could be your x1, your y1. So you're going to substitute those coordinates into your x1, y1. So I get y minus a negative 6 equals the slope, which is 11 tenths, times x minus a negative 6. So x minus x1. Okay, now remember, you need to rewrite this. So don't leave it as y subtract negative 6. You need to know that y subtract negative 6 is y plus 6, because remember, you're adding the opposite. The opposite of negative 6 is a positive 6. So that becomes y plus 6 equals 11 tenths times x plus 6. All right, so that's your point slope form. That's point slope form. Okay, now we got to write it in slope-intercept form. So we're going to distribute. So I get y plus 6 equals 11 tenths times x is 11 tenths x. 11 tenths times 6, 11 tenths times 6, 11 tenths times 6. Let's reduce. 2 into 5, 2 into 10 is 5, 2 into 6 is 3. So I get 11 times 3 is 33. 5 times 1 is 5. So I get plus 33 fifths. So 11 tenths times 6 when multiplied and reduced is 33 fifths. Then we subtract 6 from both sides. And so I get y equals 11 tenths x. And then just use your calculator to figure out what 33 fifths subtract 6 is. So 33 divided by 5, subtract 6 equal, so that's just 6 tenths. And you should know that 6 tenths reduces 6 tenths reduces 3 fifths. If you didn't know that, just say second P or B, press equal, and you get 3 fifths. So positive 3 fifths. Okay, so that's your answer in slope-intercept form. So the slope is 11 tenths, which is what it's supposed to be because that's what we found right here. And now we know that the y-intercept is 3 fifths, so the graph's going to cross the y-axis at 3 fifths. Okay, so that's slope-intercept form. And now you got to put it in standard form. So remember, standard form, bring all the variables one side, constants on the other, no fractions. So now I have fractions here. So I got to find the LCD. So the LCD of 10 and 5, and remember this is y equal 1. So 1, 10, and 5 is 10. So I'm going to multiply both sides by 10 because you don't want any fractions in your standard form. So I'm going to go ahead and rewrite this over. Y equals 11 tenths x plus 3 fifths, and multiply both sides by 10. What you do one side, you do the other. So don't forget to put this in parentheses though, because you have more than one term. So all these have to be multiplied by 10. So I get 10y equal, and I'm going to distribute. So 10 times 11 tenths x is just 11x. So remember, the whole purpose of multiplying by the LCD is to get this denominator to be a 1. So if I reduce, 10 to 10 is 1, 10 to 10 is 1, 1 times 11 is 11. So I get 11x. Plus, and then 10 times 3 fifths, 10 times 3 fifths, I'm going to write this 10 over 1. So remember, the whole purpose of multiplying by the LCD is to get this right here to be a 1. 5 into 5 is 1, 5 into 10 is 2, 2 times 3 is 6. Okay, so now remember, this is not standard form right here because I don't have the variables on the same side. So I'm going to subtract 11x from both sides. And let's rewrite this, putting the x term first. So I get negative 11x plus 10y equal, this is 0, 11x minus 11x is 0, 6. So that's your standard form. Someone else could have done this problem and gotten this standard form. So remember, what's going to be the other answer? The other answer is going to be, for standard form, the other answer is going to be 11x. So you just change the signs. You multiply everything by negative 1, or you just taking the opposite of every term on both sides. So the opposite of negative 11x is 11x. The opposite of 10y is negative 10y. And the opposite of 6 is negative 6. All right, so either this one or this one is correct. That was number 3. Number 4, you have, let's say, 8, 7, and the other point, the other ordered pair is 7, 8. So they're your two ordered pairs. Okay, so again, in order to find the equation of a line, I've got to know the slope. I don't know the slope here, so I got to find it, but I do have 2 points, so 2 points will help me to find the slope. I'm going to use a slope formula. So the slope formula, remember, is y2 minus y1 over x2 minus x1. So let's call this x1, y1, and then let's call this x2, y2. And so I get step 1 to find a slope. And so I get what equals, slope equals 8 subtract 7 divided by Okay, since I started with y2, I got to start with x2. So 7 subtract 8. So x1 is 8. So 8 subtract 7 is 1. 7 subtract 8 is a negative 1. You need to know that 1 divided by negative 1 is a negative 1. So you got to leave it, you got to rewrite this. Don't leave it like this. Rewrite it as negative 1. That's something you need to know. Okay, so there's your slope. Slope is negative 1. All right, so now step 2 is use point slope form now. Okay, so point slope form. Y minus y1 equals the slope times x minus x1. All right, now in order to use this, in order to substitute information into point slope form, I got to know the slope, which I do. It is negative 1. And I got to know a point on that line. And I know 2 of them. It does not matter which one I use. Let's go ahead and use 8, 7. So we're going to use 8, 7. Someone else could have used 7, 8. You'll still get the same answer. So y subtract, okay, remember this is going to be x1, y1. You're going to substitute that into x1, y1. So y1, 7. So y subtract 7 equals the slope, negative 1, times x subtract 8. x1 is 8. So this is point slope form. All right, that's point slope form. So now we're going to get it in slope-intercept form. So first of all, let's distribute. So you get y minus 7 equals negative 1x. Negative 1 times x, negative 1x, or just negative x. Negative 1 times a negative 8 is a positive 8. Adding 7 to both sides, and combining like terms, I get y equals negative x plus 8 plus 7 is 15. So there's your slope-intercept form. Slope-intercept form. All right. Now we got to put it in standard form. So standard form, notice there's no fractions. That's going to make it easier on you. So there are no fractions, so you bring the variables to one side. So let me go ahead and just rewrite this. I get y equals negative x plus 15. So to bring the variables to one side, I'm going to add x to both sides. And so I get x plus y equal, negative x plus x is 0, and so I get 15. So there's your standard form, x plus y equal 15. You could have also had this answer. What's the other answer for that you could have had? Well, you could have had negative x minus y equal negative 15. That's the other one. So you see how I added x to both sides? I could have brought everything to this side first, brought the 15 over, and I would have gotten this one right here. All right, so that was number 4. Okay, number 5. Let's suppose our 2 points are going to be 6, 2. There's my first point. And the other point of the line is 0, 0. Remember, 0, 0 is the origin. Remember, that's the origin. That's the origin. Okay, so again, we got to find the slope. So this is your x1, y1, x2, y2. So step 1 was to find the slope. Find slope. So slope formula, m equals y2, which is 0, subtract y1, which is 2, divided by, now remember, since our y2, I got to start with x2, 0, subtract 6. So I get 0 subtract 2 is a negative 2. 0 subtract 6 is a negative 6. I can reduce, and also know that negative divided by negatives are positives, and so I should get 1/3. So my slope is 1/3. So I know the slope. I just got to now substitute everything into the formula. So step 2 is to use point slope form. All right, so y minus y1 equals the slope times x minus x1. So it doesn't matter which point I use. I'm going to use both. I'm going to do it both ways this time. So let's use the first one. Now, you see how you have that 0? If you have a point, if one of your points has a 0 as one of the coordinates, I would use that one. It makes things a lot easier for you. And you're going to see what I mean when I do both of those. So let's use this one first, just to show you. So 6, 2, so this is going to be your x1, y1, substitute into here. I get y minus y1 is 2 equals a slope, which is 1/3, times x minus 6. All right, so that's your point-slope form. That's in point-slope form. Okay, now you get into slope-intercept form. So to get in slope-intercept form, we're going to distribute first. So y subtract 2 equals 1/3 times x is 1/3 x, minus 1/3 times the negative 6, 1/3 times 6. Reducing, in this case, I can reduce, and I get 1 times 2 is 2. So 1/3 times the negative 6 is a negative 2. And then finally add 2 to both sides. Combine like terms, I get y equals 1/3 x, and that's just 0. So the answer is just y equals 1/3 x. All right, so the slope is 1/3 and the y-intercept is 0. Okay, now let's put this in, let's go ahead and let's use the point 0, 0 this time. So let's use 0, 0, just to show you get the same answer. And it's actually going to be easier. All right, so I get y minus y1, which is 0, equals the slope, which is 1/3, times x minus x1, which is 0. Well, y minus 0 is just 0. I'm sorry, y minus 0 is y. And then over here, what's x minus 0? Well, x minus 0 is just x. So that's just 1/3 x. You're done. Okay, see, we had to do a little bit of work here. Here I didn't. We're done. Because y minus 0 is y, x minus 0 is x, and then 1/3 times x is 1/3 x. All right, now let's get into standard form. Okay, so get into standard form, remember we've got to clear the fractions and bring everything to one side. I'm sorry, bring the variable terms to one side, constants on the other. All right, so I get, I'm going to go ahead and rewrite this over, y equals 1/3 x. So the LCD is 3. So I multiply both sides by 3. So 3 times y equals 3 times 1/3 x. So notice this time I'm not using parentheses because there's just one term here. 3 times y is 3y. And then 3 times 1/3 is 1. 3 times 1/3, 3 times 1/3. 3 and 3 is 1, 3 and 3 is 1, 1 times 1 is 1. So that's just 1x or just x. All right, bring so I clear the fractions. Now I'm going to bring the terms to the variable terms to the left side. So I'm going to subtract x from both sides. All right, so I'm going to get negative x plus 3y equal, now you got to have something on this side. So remember, x minus x is 0, so you're going to put 0 there. So there's your answer. So that's your standard form. Someone else could have rewritten it as positive x minus 3y. So the opposite of x is x, the opposite of 3y is negative 3y, and the opposite of 0 is 0. Okay, so either one of those is fine. Both of those are correct. All right, so your answer for slope-intercept form is this, and your answer for standard form is one of these. Okay, finally, let's do the last one. So the last one's going to be number 6. And in number 6, suppose we had the point, the 2.6, negative 2, and negative 3, 4. 6, negative 2, and negative 3, 4. So again, if I'm going to find the equation of a line, I've got to know the slope of the line, which I don't, but I do know 2 points on that line, so I can use a slope formula to find the slope. So let's call this x1, y1, x2, y2. So slope equals, y2 is 4, subtract y1's negative 2. Now since I started with y2, I got to start with negative, with x2, so negative 3, subtract 6. All right, now be careful with the numerator. So 4 subtract negative 2 is really 4 plus, change the subtraction to addition. So you're going to add the opposite, and the opposite of a negative 2 is a positive 2. So the numerator is 6. The denominator is negative 3 plus a negative 6, so that's a negative 9. So reducing this and rewriting it, rewriting it so the negative is in the numerator instead, I get negative negative 2, they're both divisible by 3, so 6 divided by 3 is 2, and then 9 divided by 3 is 3. So my slope is negative 2/3. Slope is negative 2/3. All right, now, so here's step 1. Okay, step 2 is to use point slope form. So y minus y1 equals the slope times x minus x1. So it does not matter which of these points I use. Let's just use the first one. So we're going to use 6, negative 2. So there's going to be your x1, your y1. So I get y minus and y1, which is negative 2, equals the slope, which is negative 2/3, times x minus x1, which is 6. All right, now you see this right here. You got to rewrite this part. So y subtract negative 2, you need to rewrite as y plus 2. So I get y plus 2 equals the slope times x minus 6. Okay, so that's your point slope form. That's point slope form. Okay, now we're going to rewrite this in slope-intercept form. So first of all, I'm going to distribute. So I get y plus 2 equals negative 2/3 times x is a negative 2/3 x. A negative times a negative is a positive. So let's kind of figure out what 2/3 times 6 is. 2/3 times 6. 2/3 times 6. A negative 2/3 times a negative 6 and be a positive number. We can reduce here. So 3 into 3 is 1. 3 into 6 is 2. So I get 2 times 2 is 4. So it becomes negative 2/3 x plus 4. So negative 2/3 times a negative 6 is a positive 4. Okay, now to get y by itself, I'm going to subtract 2. Right now I'm adding 2. The opposite is subtract 2. And then combine like terms, I get y equals negative 2/3 x. A positive 4 and negative 2 is a positive 2. So there's your slope-intercept form. Slope-intercept form. Okay, now we got to put it in standard form. So they also want you to put it in standard form. So in standard form, if you're going to first of all clear the fraction, so notice the LCD is 3. The LCD is 3. So I multiply both sides by 3. So let me go ahead and rewrite this over. All right, so multiply both sides by 3. Multiply the left side by 3. Now since the right side had more than one term, I'm going to put that in parentheses and we'll multiply by 3. And then we distribute. So remember, the whole purpose of multiplying by 3 by the LCD is to get this denominator right here to be a 1. Okay, so we get 3y equal, all right, positive 3 times a negative 2/3 x will be a negative term. So let's kind of figure out what 3 times 2/3 is. 3 into 3 is 1, 3 into 3 is 1, 1 times 2 is 2. So 3 times a negative 2/3 x is a negative 2x. If you want to write the negative there, you could. So it's a negative 2x. 3 times 2 is 6. So I get 3y equal negative 2x plus 6. Now bring all the variable terms to one side. I'm going to add 2x to both sides. I get 2x plus 3y equal, this is 0, negative 2x and 2x is 0, I'm left with 6. So there's your standard form. All right. Now someone else could have brought all the variables to the right side, constant to the other side, and what do you think they would have gotten? Well, they would have gotten negative 2x minus 3y equal negative 6. All right, so it does not matter which answer you put, which equation you put for standard form, this one or this one. But all of you should have the same answer for slope-intercept form because you solve for y. So some of you could have this for standard form, some of you could have this for standard form, but all of you should have this for slope-intercept form. Okay, so that takes care of this lesson. So you should have enough problems. That should have been enough for you to understand how to find the equation of a line when 2 points are given, and eventually writing the equation in both slope-intercept form and or standard form. All right, so that takes care of this lesson.